At the end of the last example, I asked you to calculate the percent yield from the first example problem that we did. And I hope that you came up with 95.4%. Let's move on to our next example. Here's an example that's going to be very typical of the type of problems that you're going to encounter in chemistry. In other words, there's no baby steps given to you here. You're given your information, two masses, one of hydrogen sulfide gas, one of sodium hydroxide. You're told what your products are. Sometimes you'll even need to figure those out. You're given your experimental yield. It says here I have 1.86 grams of sodium sulfide produced. That means that would be my actual or experimental yield. And it asks you to calculate your percent yield. So obviously your first step is going to be to balance this chemical equation. So I'm going to ask you to pause the video at this point and go ahead and take a Okay, I hope that this is the equation that you ended up with. And the first thing that we need to do, since we are calculating percent yield here, you know that percent yield is your actual or experimental yield, which was given to us here, divided by the theoretical yield times 100. So what we really need to calculate here is our theoretical yield eventually, and we can't calculate our theoretical yield without first calculating or finding out what our limiting reagent is. And there are two ways that you can go about finding this out. One is you're given gram amounts here of both of your reactants. We have 1.50 grams of the hydrogen sulfide, and we have 2.00 grams of the sodium hydroxide. If you take each of these numbers one at a time, convert to moles, and then divide by the coefficients given to you in the balanced equation, you can just by inspection, look at those numbers, see which one is smallest, and that will be your limiting reagent. So let's go ahead and quickly do that. Our molar mass for hydrogen sulfide is 34.09. And we have a coefficient here in our balanced equation of 1. So our final answer here is going to be 0.0440 moles of H2S. Now let's go ahead and do the same for our sodium hydroxide. Dividing by our molar mass of sodium hydroxide, which is 40.00 grams, then we need to divide whatever we come up with there, again by the coefficient in the balanced equation, which this time is 2. And you're going to end up with 0.0250 moles of sodium hydroxide. Now looking at these two numbers, we can just compare them and figure out which one is smallest, and that's going to be our limiting reagent. And as you can see, that is the sodium hydroxide. I'm going to go ahead and clear my screen and show you one other way that you can do this. As I said, there's a second way to do this, and I'm going to go ahead and show you how to do that. I can start with either one of these gram amounts, and what I'm going to do is move through a conversion and find out if I started with that gram amount, how many grams of the other reactant would I need. As I said, you can start with either one, but I'm going to go ahead and start with the hydrogen sulfide gas. So I have 1.50 grams H2S. I'm going to divide by the molar mass, which is 34.09 grams. Now I need to use my mole-to-mole ratio, to move from moles of H2S to moles of NaOH. So I have, according to the balanced chemical equation, 2 moles of NaOH compared to 1 mole of, oops, excuse me, I need to reverse that, don't I? I have 1 mole of H2S and 2 moles of NaOH. Now I'm going to go ahead and get into grams of NaOH by multiplying by the molar mass. Take a look at your unit cancellation as always to make sure you set things up right. And if I were to multiply this through, I'd come up with an answer of 3.52 grams of NaOH. Now what's that saying here is if you used up all of this 1.50 grams of hydrogen sulfide, you'd need 3.52 grams of NaOH. Now you have to ask yourself, do I have 3.52 grams? And clearly you only have 2, so this is going to be your limiting reagent, and the hydrogen sulfide gas is going to be your reagent in excess. So now that we know what our limiting reagent is, let's go ahead and calculate our theoretical yield. And what we're looking for, the product that we're looking for, is our solid sodium sulfide. Remember, always start with the limiting reagent, and in this case, that's our sodium hydroxide. I'm going to go ahead and convert this into moles using the molar mass of sodium hydroxide. Now my next step is going to be to use the mole to mole ratio to compare my sodium hydroxide to my sodium sulfide. And finally, I need to convert my moles of sodium sulfide into grams of sodium sulfide using the molar mass. And that molar mass would calculate out to 78.05 grams. As always, let's check and make sure our units canceled out. Make sure that we set this up properly. And so if I put this through in my calculator right now, you should find you get an answer of 1.95 grams. Now, since I started with my limiting reagent and I worked through the conversion over to my grams of product, this would be my theoretical yield of the sodium sulfide solid. In the problem up here, it told us that our experimental yield, or actual yield, is 1.86 grams. So now I can go ahead and calculate in one last short step our percent yield. So I have 1.86 grams, which is our actual or experimental yield, divided by 1.95 grams, which is our theoretical yield, times 100 gives us a total of 95.4% yield, which is really a pretty good yield.